Hello, everybody. Thank you for attending the Petrosys webinar on automated surface modeling workflows. My name is Alec Kalingas. I'm one of the technical people out of the Houston office and will be running us through today's presentation. Before we get going, I'd just like to discuss what exactly is it that we mean by automated workflows. And basically, there's three main functions that these offer. One, when you have a workflow, you can create a user interface that'll prompt you for just key input parameters that will be fed into the workflow, which alleviates you from going to each individual task, editing each task, and resetting parameters in each individual task. You can just prompt people for them before the workflow is executed. Second thing you can do is you can share parameters between tasks in a workflow. It's quite common that a workflow might consist of many different steps and tasks. So for instance, you might want to specify just a single grid cell size and want to pass that grid cell size to each step in the entire workflow. Or perhaps step number 3, for whatever reason, needs some output, an output grid that was created in step number 1, and you want to automatically feed that into step number 3. These sorts of things. You can pass any parameter from any step into any other step in the workflow. And also you can create repetitive loops. So if you have the same sort of thing you need to do, but you need to vary a parameter. So for instance, if you're not sure of an oil-water contact and you're trying to create volumetrics over a range of contacts, you can set up a loop so that it will iterate and just change that number and a certain amount over each iteration of the loop. Or you might have several Excel files that you need to grid all at once, or several columns in an Excel file, and you don't want to copy and paste tasks and reset all the Excel files and the columns in the Excel files for each of the tasks. You can just create one grid task and loop over the columns in Excel files. And in the end, the whole thing about automation is it makes complicated workflows just a lot easier to alter and execute, because you're only prompting people for key bits of information before they're executed. And because of that, they're less prone to user errors. You might have a workflow with 20 or so steps, and if you want to change something, you might find yourself editing all of those steps and changing grid cell sizes or input grids in different tasks that come from previous tasks. It just prevents a lot of user errors with regards to those kind of things. But the most important thing is if you spend the time to create a standardized workflow, something that you want to run over and over and over again. For instance, maybe you have something set up and you have to regenerate maps every week as data changes, or you have a common workflow that you want all of the people in a business unit to follow when they're doing something like a depth conversion or volumetrics run or whatever. You can set up standard workflows that can be shared by different people in the business unit. With that said, let's just get into a quick demo. This whole thing will take about 20 minutes, by the way. And if you have any questions during the show, feel free to key them into the questions area in the webinar interface. I'll try to get to those at the end of the presentation. First off, just a quick and easy example. We're looking at a grid here, and I can tell that the grid cell size is incorrect. The contours are much too blocky, and this is pretty common. The grid has been created with a grid cell size that's way too big. And this is the task that created that grid. And if we look at it, it's just a typical grid create grid task. And if we go to the output geometry tab, we notice that the grid cell sizes have been set to the incorrect value. Those should be more like 200 or 100. And this is how people typically fix these sorts of things. They'll edit the task, they'll find the parameters that are not quite right, and they'll fix them. However, it's better if you use this button right here. It's the Specify Task Scripted Parameters button. It's the little icon with a wrench. And if you click this button, it brings up a rather long spreadsheet. And what you're looking at here is all of the user inputs in that task are found inside the spreadsheet. The group, this is the output, or I'm sorry, the tab in the interface that those options are found under. So again, if we go back in here and look at this task, the geometry tab has all of these parameter settings. So if we look at the scripted parameters worksheet for that, the geometry settings are right here under the geometry. These are all the things that you would find on the geometry tab. And we can see right here our grid cell X direction, grid cell size, and Y direction are both currently set to 5,000. Now the easiest thing you can do is click this button down here in the lower left that says Set Interactive. And if I click that, you'll notice it puts some sort of codish gobbledygook over here. This is the script. And if I click the Y one and say Set Interactive, since it's interactive, what interactive means is when I run the task, it'll pop up a user interface that allows me to specify a grid cell size at runtime. Now I'm going to cancel that because I don't like the prompt that's being displayed to the user. It's kind of cryptic. And also I only want to have one prompt that sets both the X and the Y grid cell sizes. So if I go back in here, I can double click this, and this is how you edit the actual script. And you don't have to know much about, these are functions that take parameters as input, but it's obvious that's the user, what the user sees in the interface. I'm just going to change this to cell size, say okay, and I'll do the same for the other one, cell size, and okay. If we run this now the interface looks much cleaner. I can specify whatever grid cell size I'd like, let it run, let it finish, come over here, redisplay my map, and it will look much better. Okay, the other thing you might want to do just for playing around, this option right here on the Methods tab is the Grid Create method. I can set that to interactive as well. Double click it to alter the user prompt, say OK, and now when I run it, it'll prompt for both things, right? So you can prompt for whatever key bits of information you would like in the workflow, right? So I'm not going to run that again. Let me open up another example. This is essentially the same thing. Sorry, wrong one. This is the same step right here that we just scripted. And if I run this, it'll look like the same interface. However, this is a 3-step workflow, and it's gridding fault planes. If we look at the second step, we'll notice a few things. One, on the geometry tab, it also has grid cell size settings that we're going to want to have match the first step. And if we look at the input data, if you'll notice, is gridding the input data that's coming out of the first step. So whatever the first step generates is what should be pumped into the second step as its input. So there's a few things here that we want to do. We want to tell the second step to pick up the grid cell sizes specified up here, and we want to tell it its input data is the output from step number 1. So again, we highlight the task, we click the scripting parameters icon, and we find the options in question. Now here's the grid cell sizes in the X and Y directions. We're not going to prompt for that. I can use this button right here, and this button will bring up a list of all of the current task parameter settings. There's also a host of functions that you can use to do string handling, like get the file extension from something or just get the file name, the file path, lots of functions that you can use. But more importantly, you can go back to any previous step in the task and get values from it. So if I look for things like cell size, here's cell size in the X direction. I can click test. You'll notice 200 is coming from the first step. And if I do the same on this one, and we will go back to the first step, and I'll grab the cell size in the Y direction and say OK to that. Now, also the input grid. Okay, if we scroll through here, you might think it's difficult to find things. I can see it down here. But don't forget, you can always sort on these different column headers. So if I sort by the tab in which things are found, I know that's specified on the input. Okay, and there it is. There's the input data that it's going to be gridding. Now I want that to come from the first step as well. So I double click it, click the plus button, go back to the first step, and grab the output grid from the first step. If I click test, you'll see that's the output grid coming from the first step. So no matter what grid file the first step creates, it'll automatically be used by this second step in the script. Okay? If we look at the third step in the process, it's a simple grid arithmetic step, and it's taking 2 grids as input, and the first grid that it's taking came from step number 1, and the second grid that it's taking came from step number 2. Okay, so those need to be scripted. We want to make sure that the output geometry is again using the same cell sizes as everything else. So if I come into here, I've already set this up just to make the show go a little bit quicker. So you can see I've scripted this to go to step number 1 and get the grid cell size from the X and Y directions. And if we scroll down to the bottom, the two input variables, I've told it, grab input grid number 1 from task ID number 1, its output grid, and the second grid, go to task ID number 2 and its output grid. And again, it's easy to do that. You just use this plus button, go to whichever task you want, and find the right parameter. Okay, so right now we have a script that's prompting for a grid cell size. That grid cell size is going to be passed through all of the steps in the process, and all of the inputs for all of the steps of the process are being set automatically. I can run that, and it'll just run through and run all 3 steps. The next thing is the idea of looping. What if I don't want to just have a constant grid cell size? Or what if I don't know the exact oil-water contact and I want to run a series of volumetrics where I alter the oil-water contact by a certain number of feet or meters? Well, what you can do is you can just click one task, shift-click the last task that you want to loop over. So get them all highlighted, and you can either right-click and go to loop over highlighted tasks, or you can go to workflow, loop over highlighted tasks. This will create a loop. And when we say a loop, it's just going to be an iterative process. It's going to run these 3 steps over and over and over again. The first thing you want to do is set up a variable to store the loop values in. The next thing you want to set up, what do you want to loop over? I could loop over a set of files, like all my XSL files, or I could loop over a set of seismic horizons. Seismic horizons can come from a variety of input data sources, or I could loop over well formation pics from, say, OpenWorks, and each iteration in the step would be feeding a different formation into the workflow process. I'm going to loop over a range of numbers, and I'm going to tell the system to start the number at 200, stop looping when it reaches 1000, and each iteration of the loop bump it by 200. So I should get 200, 400, 6, 8, and 1000. Okay. Next thing, we don't want the grid cell size to be prompted for any longer. We want to pick that up from our loop. So if I come here and click on the task parameters, all right, we don't want this user prompt anymore. I'm going to clear that. We simply want to use that plus button, go back to our loop begin task, get rid of this filter, and use our cell size that's coming in from that task. This is the thing that's going to go from 200, 400, 600, 8, and 1000. Say, okay, we need to do it for this as well. We'll clear this, go to our loop, and get the cell size. Okay, so the cell size is now going to vary for each of the iterations of the task for this particular step. If we look at the second step, look at its parameters, the cell size is already going to vary because it's picking up the cell size from task ID number 1, and the cell size in task ID number 1 is already changing, so this step is already set up and just fine. If we go to this step and look at its parameters, it's pretty much set up as well. Okay. The only thing this really needs to change is the name of the output grid. Right? The name of the output grid right now is going to a subdirectory called saved output, and it's sort of hard-coded. We want to append on the grid cell size to the end of the grid name. So what I'm going to do, set this to still saved output / and I'll keep pretty much the same name, underscore, but I want to append on my cell size, which again is coming from the loop in this variable called cell size .gri. I can click the test button, and you'll notice the first iterative value in the loop is 200, so that's what the test value is showing. Okay, so now if I say OK, and before I run this, I'll pop up a file selector. This is where all of the output data is going to be going. Okay? If I run this now, you see it no longer is prompting for the cell size. It's going to be getting the cell sizes from our loop. Say, all right. So you could see the 200 building, the 4, the 6, the 8, and the 1000. It'll stop. Right. So that's the first example of a loop. Another example of a loop, if I go to File and just open up a new task. This is a simple task. It's again a grid create grid task, and it's putting all of the output data, output grids in a subfolder called formation attributes. And notice the convention in the file name that is creating. That's the name of the formation underscore and some attribute. And if we look at the input data for this particular gridding task, you'll notice is this gridding data from an Excel file. But this Excel file has other attributes. It's got porosity, V-shale, saturation, pressure. Okay. I've also got multiple Excel files in the formation name underscore attributes.xxl, and they have the same columns in them. I can pop up the spreadsheet. This is the actual spreadsheet that we're going to be gridding, and I want to iterate over each of these 4 columns and automatically make 4 grids. So normally we see people copying, pasting this grid, create grid. They would make 4 different steps here, but we're not going to do that. We're going to right click. We're going to loop over highlighted tasks. I'm going to make an attribute or called attribute, and we're no longer going to go over a range. I'm going to loop over just a set of hard-coded string values. And all this is those column names that were in the Excel spreadsheet. I just copy and pasted them in from the spreadsheet into this interface. Say OK to this. So now it's embedded inside of a loop. If we look at the parameters for the task itself, notice the output grid is hard-coded to Willrich underscore porosity. We don't want porosity hard-coded in there anymore. We want to append on the name of the attribute that we're going to be gridding. So we'll still write it to formation outputs. We'll still call it Willrich underscore. We won't hard-code porosity. We'll go back to our loop and we'll get the value from our attribute variable .gri. Okay, we'll say OK to this. I'll pop up a different file selector. This is where all the output is going from this task. We'll say OK to that. And you'll notice it makes the 4 grids, Willrich, porosity, blah, 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 blah. All right? But again, we have 4 such Excel files. And again, just to review, if we look at what Excel files we have, they're the same formation names underscore attribute.xls. So I want to loop over these 4 files. There's 4 columns in each, so that gives us a total of 16 grids that we want to create. So again, what we're going to do is we're just going to make another loop. We activate all the things that we want to loop over. In this case, this is including the loop. You can have loops embedded inside of loops. I'll say loop over highlighted tasks. We'll change our parameter name to formation, and this time I'm not going to get it from strings. I'll use this option, strings from file. All I've done here is I've created a file that has the formation names in there, and those were the names of the Excel files underscore attribute.xlsx. All right, so now we have a loop within a loop. If we look at this option again, okay, we no longer want to just have this hard-coded to Willrich. We want that to pick up the formation name from our formation loop. So I can go back to the first loop, pick up formation, say OK. Now that's in the wrong place. So I will cut that out and I will replace that with Willrich. And if I say OK, it's OK. So it's picking up the first value, formation name, porosity.gri. That's going to be the name of the output file. All right. We sort on group. Okay, we no longer want to grid this hard-coded Willrich attribute file any longer. That needs to change with each iteration of the group. So we're going to set that again to the name of our formation underscore. Okay, so that's going to be the formation name underscore attributes. It was Willrich, and now it's going to be looped over. Also, and there was one thing that I forgot to change in the previous step. We don't want to hard code the column name. That needs to be looped over as well. So the column name that we're going to go over is coming from our inner loop, the attribute. If I click test, and we'll see the first value from the loop coming out of it. Say OK to that. We'll run this. And those grids are going to overwrite. So now you'll see it's gridding over the different Excel files. There's 4 attributes in each Excel file, and in the end we get a total of 16 grids. So it's very much more convenient, and that means if I've made a mistake inside of the step, I only have to fix it in one place. I don't have to go fix the same thing in 16 different tasks. There's another example. In the last example, I will just open up a different map and a different worksheet. This map right here is just a seismic horizon in the Gulf of Mexico. And this is what I'm calling a template map sheet. One of the things that I'm going to be doing here is I'm going to be looping over seismic horizons, and I want to do various things. Now, this is a fairly complicated workflow. For instance, this step right here is looping over a whole host of seismic horizons, and it's performing a time depth conversion step on each. Once things are depth converted, this one is again looping over the same horizons and is generating a lot of output data, a lot of output files. I'm not going to run the entire workflow. It does take about 5 minutes to create, but we're just going to run this output thing here. One of the things that's interesting is you can create output directories. And I don't know if you know this, but there's a lot of options under tools, and there's a tools create directory. So I'm going to create a directory for each of my horizons, and then inside of that directory I'm going to create different things like a Petrosys 2D map DBM file that I can open up over here in mapping to view the map. There's Adobe PDF files that are being exported, and a variety of raster files that are being exported. I currently have those turned off just to make it run faster, but I'm creating files for Landmark, files for our Esri community, and finally it's doing a CRS transformation. I just have a few of these turned on. If I open up again another file selector to show you where these files are going to be going, it's empty. If I run this, so it's going to create a directory for each of my horizons, and you can see it's going to repeat all of these steps. It's just looping over these steps right here. And what it's done is it's created a directory for each of my horizons. And if I go into one of these directories and see what it's made a DBM file. That was this step right here. It's made the ArcGIS grid. That was this step right here, and 3 different ZMap files. It's my steps right here. Okay. And what's interesting about this step, I think, the create DBM file, is that you can make what's called a template map. That's what this is. And you can take that template map and you can make new DBM files. And again, these are all just the scripted parameters. If we look at this create output directory, for instance, it just has one parameter. What directory do you want to create? Well, I've scripted that to pick up the name of the horizon. And it's the same with all of the steps. I've just scripted all of these steps to get the name of the horizon and make various different files. So now that I have a whole bunch of DBMs, I can do things. Go to File, Open. We'll move away from the template. We'll go to Saved Output and maybe grab our Jurassic. I'm going to copy the word Jurassic just to make my life a little easier, and we'll display that DBM file. It'll take a moment to display. All right, so this is what it came up with for the depth converted Jurassic horizon. I can take all 4 of these, right click, and go to Create Group. And I'm going to call this group Jurassic. And I'll collapse the group. Now I can go to File Merge, not File Open, but File Merge. Again, go back to my saved output and go to a different one, maybe the top of salt. And I'll copy that again because I'm going to need it for my group, and I can bring in that DBM, and I'm going to pack all of those into their own layer. So you click, right click, create a group, and I'm going to call it top of salt. All right. Now I could do that for all of the horizons that I've created, but I'm not going to go through that and waste everybody's time. But the point is, after you've made a nice, concise set of layers, you can always go to File, Export, and you can create a PDF file. This option right here, File, Export to PDF. And what that does is it makes a georectified PDF file, and here's the example. I've included, 4 of those horizons that I've created. And what's nice about these is if somebody wants to view a map, as long as they have Adobe Reader on their machine, they can look at these maps as much as they want. All of the layering information from the Petrosys DBM file is preserved. They can turn things on, turn things off, and it just makes for a nice, easy way for users to look at your results. Okay, so let's go back to the PowerPoint. That's really the end of the show, but just to review, we like to see people use these because they can make complicated workflows just a lot easier to work with and execute. If you have a workflow with even 5 steps in it, you don't want to find yourself hunting and pecking for different things to edit with each run of the workflow. So you want to prompt people for key bits of information and share bits of information between the steps. And that makes these things a lot less prone to user errors. But again, the most important thing is that you can create standardized workflows that you can run every week on different horizons, different groups of horizons. It might be the same sort of horizons that's just bringing in new data and refreshing maps and refreshing grids that you might need for other processes on a weekly basis. Okay, so that's really all I had to say. Again, if you have any questions, feel free to key them into the question dialog in the in the web interface, and you could take note of these various links. Now, we will be posting a recorded video of this session on our website. So if you go in a day or two to petrosys.com.au, and if you go to our support area, you'll see a place where you can download the video. But anyway, again, if you have any questions, feel free to key them in. But if not, thank you for taking the time to view this webinar. Goodbye.